All right, everybody, we are going to take a look at lines that are tangent to the circle and trying to write the equation of that tangent line. So here I have graphed the circle with the equation of x minus 3 squared plus y minus 2 squared equals 25. That information tells us that our center of our circle is at 3, 2, and that our radius was at 5. So you can have that sketched out and go ahead and get that done. And then you can pause and come back and get ready for the fun. So the first thing we're going to do is draw a line tangent to the circle. That question is down here at the bottom. Draw a line tangent to the circle at the point 7, 5. 7, 5. So if it's tangent to the circle, we have to remember from our lesson yesterday that the tangent line is perpendicular to the radius. Perpendicular to the radius. So the first thing I'm going to do is plot that point at 7, 5. 7, 5 right here. And I want to know what to write for the equation of this line. In order for me to do that, I need to find a slope. I'm going to need to find a y-intercept. But the first thing I'm going to need to do is find a slope. In order for me to find the slope, since it's a tangent line, and so it is perpendicular to the radius, I must start with the radius of the circle. So my step one is the slope of my radius. That's the first thing I am going to find. So if I connect my center to that point, that creates a radius. And I'm just going to use rise over run to calculate the slope. So I go up 1, 2, 3 steps and over 1, 2, 3, 4. So the slope of the radius is 3 over 4. So since this is perpendicular, I need to take the opposite reciprocal of that slope to find the slope of my tangent line. So the perpendicular slope of 3 over 4 is going to be negative 4 over 3. So that is the m of my tangent line is negative 4 over 3. So now I have the point and I have the slope. So I'm going to use point slope form to write the equation of my circle to put it into slope intercept form. So I have my point, which is at 7, 5, and my slope of negative 4 over 3. So y minus my y1 is 5 equals my slope, negative 4 over 3, parentheses x minus 7. So if I ask for the answer in point slope form, there's your answer. And if I want it into slope intercept form, I'm going to need to go ahead and multiply this through. So I'm going to distribute my slope. That's negative 4 over 3x. And I'm going to take a negative 4 over 3 and multiply that to a negative 7. And that gives me a positive 28 over 3. And now I'm going to need to bring that 5 over. So I add that 5 to both sides. That 5 I can rewrite as 20. Let's see, put 5 here. 5 is the same as we're doing with 3, 15 over 3. So y is equal to negative 4 over 3x. 15 plus 28 is 43 over 3. So the equation of our tangent line is y equals negative 4 over 3x plus 43 over 3. Next, we are going to do part B. And part B here says, is the line, so it gives us an equation of a line and is asking if it is tangent to the circle. So I am going to clear out some of this work. And we are going to check to see if that line is tangent to the circle at -1, -1. So in order for me to do that, the first thing I'm going to do is plot that point of -1, -1 right here. And I'm going to check the slope. To see if they are perpendicular. So I have my radius that I'm going to draw from the center to my point. And again, you can use slope formula if you prefer, or you can do rise over run. So I'm going to do rise over run. So from my center, I go down 1, 2, 3. So down 3 and over 1, 2, 3, 4. So my slope of the radius, I'm going to put that in a different color. Slope of the radius is -3. Oh, we're going in the opposite direction. That's right. So if you go from the point, it's negative, negative, so it turns into a positive. So it's 3 over 4. And then we want to check to see if the slope of our equation is perpendicular. If this was perpendicular, it would need to be -4 over 3. But if we look at our equation, that slope is -3 over 4. Is that perpendicular? No, it is not. It is very much not perpendicular. Now, the last thing we're going to do here is determine where, we have an equation of our line that's tangent, and we want to find the point. So we want to find the intersection point of a circle and a line. This is something we have done before, so we will use those skills again. Get all of my workspace kind of cleaned up. Oh no, I didn't want to erase my circle. Okay, let's see if I can get that with, yes, there we go. Got it without erasing the circle. Okay, so we have an equation of a line at, let's see, what color do I want to use? 3 over 4x plus 6. So I'm going to determine, using my equation of my circle, I'm going to write that down here. We have x minus 3 squared plus y minus 2 squared equals 25. And then we have our equation y equals 3 over 4x plus 6. So I'm going to use substitution to replace y in my equation of the circle with the equation of the line that's tangent. So I'm going to replace y with that. I'm going to take y out of the situation and replace it. So when I do that, we get x minus 3 squared plus parentheses 3 over 4x plus 6 minus 2 squared equals 25. So we're going to go through and FOIL all of this. So we have x minus 3 plus, we can combine our like terms on the positive 6 and negative 2. So I combine those and we have 3 over 4x plus 4 times 3 over 4x plus 4 equals 25. So I'm going to take that over here and FOIL, and we get x squared minus 6x plus 9 plus 3 times 3 is 9, 4 times 4 is 16. So we have 9 over 16 x squared. And then when we multiply 3 over 4 times 4, the 4's are going to cancel out. So I have 3x and 3x. Together that is 6x. And then negative or positive 4 times positive 4 is 16 equals 25. So now we need to go through and combine like terms. If I look at this, I have a positive 6x and a negative 6x. So those are going to cancel out. So then I'm going to go through and combine everything else. So we have 1 full x squared plus 9 over 16. That makes 25 over 16 x squared. 9 plus 16 is 25 equals 25. When we subtract that 25 out, we have 25 over 16 x squared equals 0. Equals 0. So if we get rid of this 25 over 16 by dividing or multiplying by the reciprocal, we end up with x squared equals 0. So x is just 0. X is just 0. Can't stress that enough. So now I'm going to plug that into my equation of my line, my original equation of the line. Y equals 3 over 4x plus 6. I'm going to plug 0 in for x. So we get y equals 3 over 4, parentheses, 0 plus 6. 3 over 4 times 0 is just 0, so y is equal to 6. So my point of intersection, where these 2 points run, or where the circle and the line run into each other for this equation, for this point of tangency, is going to happen at 0, 6. So let's take a look. 0, 6, 0, 6 is right up here in that top corner. So this would have been our radius, and our line of tangency would have gone across like that to create your right angle.